Hello and welcome back, everyone. We are moving into Chapter 5, which we have talked very briefly at a broad level about a couple of times up until now, which is the diversity of values in a group. So last week when we talked about central tendency and the mean, median, and mode as measures of what is typical, we also mentioned that in order to know what is typical, we also need to know more about the data distribution and the diversity of values in a group, because what is typical doesn't necessarily reflect how much diversity there is around that measure. That's what measures of variability will tell us. And we're going to cover several measures of variability. Again, this is the Stata-specific tutorial, so we're going to learn how to, in Stata, find the range, the interquartile range, the variance, and standard deviation. And again, this is assuming you've already read the chapter and understand what these things are. And these things will tell us how much diversity there is on a particular variable in the sample or population. How are the scores distributed? We learned how to actually visualize this as histogram data or bar charts previously, and now we're actually quantifying that using these measures of spread or dispersion or variability. I'm using those terms interchangeably. All right, so let's get right into Stata here. For this chapter, we are working with the World Values Survey. The data were collected from respondents from multiple countries in the world. The World Values Survey we've used in a previous tutorial looking at the individual respondents' data, and the unit of analysis, throwback to Chapter 1, was individuals. People responded to those survey items, and that is when we use this WVS, the World Values Survey Wave 6 data. For this chapter, for this tutorial, the individual level data have been aggregated, that is, they have been summarized up to the country level. So in this WVS Wave 6 means data set, which is the one we're going to be using right now, we have country level data. So we took all of the responses from the individuals within each country, and we aggregated and got the means for the country variables, and now we have a data set that is country level unit of analysis. So let's open, I did it fine last time and I forgot this time. Let's open up with Stata 15, the WVS Wave 6 means.dta. If you're following along and you opened up your data set and you have a lot more variables here, you used the wrong data set, go back, close that, and look for the one that has WVS Wave 6 means.dta. So you'll see in this data set we only have 4 variables. The country code, a variable, actually these variables are not labeled well. They're the means of the variables from the individual level data set, and I'll have to tell you what they are because the labels don't tell you that, which is the response to the average response at the country level to a particular question on the World Values Survey. That question asked, I'm interested in how you think most people in this country view the position in society of people in their 20s and people over 70. Using this card, please tell me where most people would place the social position of people in their 20s and people in their 70s. And we actually have the variable for people in their 40s as well. So if we just type in browse, which I always like to do when I first open up a data set, that allows me to see what I've got here. So 4 variables in the data set, 60 observations. What do those observations represent? Are they individuals or are they countries? If you said countries, you are correct. We have, again, this data set is aggregated up to the country level. So you can see this V2 is the country code, and there are 60 countries included in our data set. So all of these other 3 variables are the mean response for respondents in each country on this particular question. So people were asked to, on a scale of 1 to 10, 1 being really low position, extremely low position in society, and 10 being extremely high position in society, to rate people in their 20s, that's this variable, and people in their 70s, that's this variable. So first notice that currently the countries are sorted. How? Does it look like they're sorted? It looks alphabetic, but then we have Taiwan. So I'm not sure how it is sorted. It may be sorted alphabetically, but Taiwan has a different coding here. There's no, doesn't look like there's any sorting on these other variables. So the variables are sorted by the response here, by the country coding. So Algeria, of all of the respondents in Algeria, we don't know how many there were. We'd have to go back to the original World Values Survey individual level data set to find that out. But all the Algerian respondents, if we summed up their responses to what's the position of people in their 20s in this country, and got the mean of that, we would get this 5.4. Well, how does that compare to the rest of the data set? We'd have to figure out what the overall mean is if we looked at the mean for all of these countries in order to find out whether Algeria is worse or better in terms of position of people in their 20s. Then we can compare that to the position of people in their 70s, which is 5.9. So on average, people in Algeria said that people in their 70s have a slightly higher social position than people in their 20s. And then we can look at these other differences between, we can look at differences between countries on one variable, like people in their 20s, and compare, say, Algeria and Colombia. Or we can look at differences in one country and compare responses on the question about people in their 20s versus people in their 70s. You probably care more about people in their 20s though, right? You're like, where should I take my next trip? So what we want to know in addition to these means is how much variation is there in this entire distribution, and again, what is the average across all of these countries, so that we can assess how one particular country does relative to other countries, and also how much variation there is across the different countries. All right, so now that we've browsed the data set, let's go ahead and open up our do file. Go up to Window, Do File Editor, create a new do file, always copying in our use command. And what else should we do? That's right, asterisk in Chapter 5 as a reminder to self that this is the Chapter 5 tutorial whenever we reuse this do file, which for all intents and purposes we probably won't, but you might use it, say, for your exams or so on, so we want to annotate it well. I also, again, I'm a compulsive saver, so I'm going to go ahead and give this a name, Chapter 5, save it along with the other do files, and now you can see that it's saved as Chapter 5 do file. And when you make changes, a little asterisk will appear indicating that you have new changes that you need to save. And if you're like me, you'll probably click the save button every 35 seconds. All right, I'm going to try to have some self-control and not save so often while we're doing the tutorial. So moving forward, we want to first find out, we could even include the browse command here in our do file to remind ourselves to take a look at our data editor or spreadsheet when we open up the program next. Next thing we want to do is figure out the range for the data, and we want to know for the question on people in their 20s and the question on people in their 70s, what is the range of data? So we can do that using the tab stat command, and I don't think I've introduced this quick tip yet, but you can click on the names of the variables if you hover over next to the name of the variable and click on that arrow, it will put it in the command window, and then you can just use Control-C to copy and Control-V to paste it into your do file editor, making it very easy to not have to type out variable names. And we used the tab stat command last time to get the mean and the mode, or I'm sorry, the mean and the median. This time we're going to use it to get the range. So the range is the difference between the highest value and the lowest value in the data set. We can actually calculate this by hand if we wanted to. If you recall, we have the summarize command. Let's actually do both of these to review a little bit. So we can summarize these two variables and see how many observations there are. So 60 countries included for both of these variables. The overall mean for all 60 countries is 5.3 for people in their 20s and 5.7 for people in their 70s. So that tells us across these 60 countries, generally the position of elderly people is higher than the position of people in their 20s. I guess it depends if you're ageist or not, whether that bugs you. But it's not only about what the typical number is, right? The mean is one number, but what we want to know is also how much variation is there around the mean. That is, remember we talked about the mean being influenced by outliers. Maybe there are some really high values that are just a couple of countries that are pulling up this mean for people in their 70s. So we want to look at some of the measures of diversity of values or of variability around the mean to tell us a bit about this distribution. We might look at the standard deviation and compare those. Actually, the standard deviation for this question is larger than the standard deviation for the question about people in their 20s. And let's look at the range. The minimum, so the lowest rating for people in their 20s is 4.5. and the highest rating is 7.3, while for people in their 70s, it ranges from 3.7. So actually there are countries that have lower ratings for people in their 70s and slightly higher ratings for people in their 70s compared to people in their 20s. We could also create histograms of each of these variables to get a sense of the data distribution. Of each of these. One of the things to remember with the Stata graphs is that you can't have two of them open at the same time. So once you run the command for this one, you have to check it out and either save it in order to have it open as a JPEG on the side. Otherwise, when you run the command for the histogram for the 70s, this one will close out first. So let's just first take a look at the distribution for people in their 20s. We can see it's approximately 3.5 to maybe a 7.5 or so, just over 7. And it's a skewed distribution with more responses right around 5 and 5.5, and then with a little bit of a tail to the right. So we would say this is a skewed right distribution because the tail is on the right-hand side. So what that means is our mean will be higher than the median, the number in the middle where 50% of the values fall below that number. So we could look at the density here and try to get a sense for where approximately 50% of respondents fall. And we may have a mean that's slightly higher than that because we have some higher values over here in the tail. Okay, so we could also just, after we close this histogram, we could also get the information for all of these three statistics, the mean, the median, and the range all at once. So here we were looking at the histogram, we did a summarize command. Now we can do, I'm going to rerun this so that you can see what I just did. Instead of running tabstat with just the range, we are going to copy that and run tabstat on both of our variables. So we want to get the statistics for both the variable about people in their 20s and about people in their 70s. And I'm going to ask for multiple statistics. I'm going to ask for the median, the mean, and the range all at once. And when you run that, you can see that you get P50. Again, that's the 50th percentile, also known as the median. And here we can see that that's 5.29 rating for the question about people in their 20s. The mean is slightly higher than that, 5.36. So that's just what we were talking about with the histogram, showing you that the mean is going to be a little bit higher, and in this case, marginally higher than the median. And the range, that is the difference between the minimum value and the maximum value, which we were able to get with the summarize command, is 3.1 for the question about people in their 20s and 3.7 for the question about people in their 70s. So these numbers are exactly the same as if we were to do the math by hand, which I will now show you how to do using the display command. Actually, I'm going to do it in the do file. I believe we've done this before. That is, use the display command, but we'll find out. So if we were to take the difference between these two variables, display essentially tells the program, show me what this equation, what the answer to this equation is. So 7.35 minus 4.25 is 3.096, and we see that that is 3.096. This is for the 20 variable. For the variable about people in their 70s, this one here, we're going to copy the range, and we're going to use display, and we're going to take the maximum value minus the minimum value. Whoops, this is where you do edit, undo. Thank God for the undo command, right? Then we highlight the line and do the command, execute the command, and we get 3.74, which is exactly this number here for the variable for people in their 70s. Okay, so we've achieved the same thing. Allows you to calculate the range. I copied the min and max values from the summarize output above so that you remember how we did that. You might want to annotate that to yourself so that you remember, this is how I can double check and get the range. Compulsive saver, there we go. Okay, so moving on, we've now been able to look at the range and see that people vary more, or countries vary more in their assessment of the position of elderly people than they do of young people, even though on average people rate the position of elderly people, the mean position of elderly people, as being slightly higher than the mean position of people in their 20s. So again, this is a case where just looking at the mean doesn't tell the whole story. Again, I'm going to digress quickly because I'm actually really interested to find out which countries have the worst ratings here. So I'm going to first sort by this variable asking about their 20s, and then browse the data. And this is going to allow me to find out which countries have the lowest ratings for people in their 20s. So you can see these other two variables are not sorted in order, but this 20s variable is sorted from lowest to highest, so in ascending order. So if we look at the very first country, that's Spain, that has the lowest rating for people in their 20s. Don't go to Spain. There goes your trip to Ibiza. And Pakistan has the highest rating for people in their 20s. Now, if we were to change the sorting order, we can close out of Browse and copy this command and do the same for people in their 70s. It's really handy that these variables are named so similarly. I just change out one digit. So now we've sorted by people in their 70s. You can see these are now in ascending order for this variable. So which country has the lowest rating for people in their 70s? Estonia. And which has the highest? Uzbekistan. Actually, quite similar to Pakistan. So Uzbekistan, Pakistan, Kuwait rate very highly the position of elderly folks. And interestingly, Pakistan also rates the position of 20-somethings really high relative to other countries as well. Okay, so now let's find out what the percentiles in the data are. That is, we know the median, which is the 50th percentile, so 50% of the 60 countries, so 30 countries fall at or below the median value, which we said was, I don't actually remember, what did we say the median value was for, say, ratings for people in their 20s? 5.3. So 50% of countries fall below that, and the rest fall above that 5.3 rating. So now we want to know where is the cutoff for the 25th percentile. So at what value do 25% or less of the respondents, sorry, not 25% or less, at what value are there 15 countries at or below that value? That was a confusing way to say it. Let's see if we can visualize it to make more sense of it. So we're using tab stat. Again, we're going to use both of the variables. And this time, instead of using these mean, median, range, we're going to do P25, so percentile 25, and percentile 75. Remember, P50, percentile 50, is the median. So now we're asking for the quartiles, Q1 and Q3, on both of these variables. And we'll see that 15 countries fall at or below a rating of 4.9 for position of people in their 20s. And very similar for people in their 70s. So there's not a whole lot of variability down at the bottom end of the distribution. But then we look at the top, and that's where these numbers vary. But this is a little bit harder to wrap your head around and quite easier to visualize, easier to understand when you visualize it. So we're going to look at what's called a box plot in order to understand where these cutoffs are. And we do that using the graph command. We've used the graph command previously to do a bar chart. Now we're doing a box plot. And we're going to do each of these variables separately. So first for the 20s, then the 70s variable. And we're going to run each of them one at a time, otherwise they will close each other out. Okay, so this is the graph for the box plot for ratings of people in their 20s. This represents, you're like, oh, this looks kind of funky. This tells you all of the information that we just talked about here, which is the minimum value in the data, the 25th percentile, the median, the 75th percentile, and whether there are outliers above that. So we can take a look at this box plot. All right, so we're looking at this box plot, and we can see that we have a 25th, this is the line where the 25th percentile lies. This is where the median is. This is the 75th percentile. And these, what are called whiskers, these lines extend 1.5 IQRs, that's the interquartile range between the 25 and 75 percentile, so Q1 and Q3. That's the distance between these two quartiles. If we take that distance and extend these lines outward, any observations that fall at values above or below those are considered outliers. So here we have the response for the question on feelings about people in their 20s. So we see that most countries, so the median response is approximately just below 5.5, and that again lines up with what we have from our output here, 5.3. But this visual helps us to get all of the information rather than in a table. It's far easier to look at the visual to compare different data distributions. So here we see the median at approximately 5.3. The range was 3.1 approximately, and we can just quickly get a sense of that by looking at this. The distance between, this is the lowest observation at 4 point something. Where was that? In the summarize command, if we go up further, 4.25 was the minimum for the response on people in their 20s, so that's this here, and the maximum is approximately 7.3, so that's this country up here. And so the distance between the 25th percentile and the 75th percentile is the interquartile range, and so observations that fall below that are outliers. So here we see 4 countries or more that are considered outliers, and they're only on the high end, which means they're much more likely to rate their feelings or the position of people in their 20s higher than the rest of the distribution. And so we can quickly compare this to the box plot for the response on the question about people in their 70s, and we see that the interquartile range is larger than it was for the other group. The boxes are further apart. We don't have any outliers also. Notice that there are no points outside of these whiskers, so there are no outliers in responses to position about elderly folks. So there's much more dispersion or variability in the responses about people in their 20s versus about people in their 70s. All right, and the last couple of things that we want to figure out is what are the variance and standard deviation. And actually we already did this at the top using the summarize command. We found the variance, but we're going to do it using the tab stat command. It's probably quickly becoming your favorite because you can just specify all of the commands that you want, or all of the measures rather that you want here. Variance and standard deviation, and we can get both of those values just by using tab stat and asking for variance and standard deviation here. Now, we already saw these further up with the standard deviation, that there's greater variation around the mean for the response to the question about elderly people. We saw that in the box plot as well. Than there is to the question about people in their 20s. And we're generally going to be more likely to use the standard deviation, which is the square root of the variance measure. The standard deviation is a much more commonly used measure of dispersion around the mean. The brilliant thing about standard deviations is that we can compare standard deviations for variables that are measured on very different scales. So for example, you can't compare the raw mean of a variable that's measured on a scale of 1 to 10 to a variable that's measured on a scale of 1 to 100. However, you could compare the standard deviations of those two variables in order to compare scores on particular measures for different scales. That we'll give examples of that in class, but that is a major benefit of standard deviations, is that we can compare variables that are on different scales, even if we can't compare their raw measures of central tendency. All right, so let's save this do file, and I believe that is all that we are going to cover today. So what did we go over? Well, we looked at using the tab stat command in order to get multiple statistics at the same time. Actually, we can get the mean, the median, the range, the 25th percentile and the 75th percentile, which also helps us to calculate the interquartile range. We learned how to create box plots in order to be able to better visualize and compare two variables or two different groups on a variable, and look at the distribution of the data rather than looking at the tables to try to understand whether there are outliers and what the data distribution is and where the mean is and so on. And all of this is in order to understand what the average deviation is from that measure of central tendency. So again, as a summary here, we have a variable, for example, the measure of position of people in their 20s is on average 5.3 in this sample of 60 countries, but with a standard deviation of 0.7. So it's a lower rating of position than the position of elderly people, but there's also less deviation around that mean than for measures for people in their 70s. All right, so thank you for joining me, and on that terrible disappointment, see you next time.